November 12, 1944, 8:41 a.m., 14,000 feet above Tromsø Fjord. Flight Lieutenant Bruce Buckham sits in the nose of Lancaster PB-416, eye pressed against the rubber cup of the SABS bombsight. His hands rest on controls so sensitive that a twitch, a tremor from the cold, a flinch from flak would translate to a miss measured in hundreds of yards on the ground below. Through the optical glass, he can see the Tirpitz, a gray dagger 700 feet long, partially obscured by chemical smoke, surrounded by enough anti-aircraft guns to fill the sky with steel. In exactly 60 seconds, Buckham will release a 12,000-pound earthquake bomb. For that weapon to hit, for the mission to succeed, for 3 years of engineering genius and strategic desperation to mean anything, his aircraft must fly perfectly straight and level. No evasion, no deviation, not for 1 second of those 60 seconds. The Germans know this. That's why they call it the dead man's run. Here's the paradox that defined precision bombing in World War II. The more accurate your weapon system becomes, the more vulnerable you make yourself, because accuracy demands predictability, and predictability in a sky filled with 88mm flak cannons firing shells that explode with surgical timing at your exact altitude is a death sentence you write in mathematics. This isn't a story of courage, though courage will be required. This is an analysis of the 60 seconds where ballistics, human nerve, and industrial violence collided at 300 miles per hour. Because in 1944, the most terrifying thing you could ask a bomber crew to do wasn't to fly into danger. It was to fly straight into it for a full minute while physics calculated whether you would live or die.
To understand why the dead man's run existed, you need to understand what made the Tirpitz different from every other target in the European theater. She wasn't a city you could saturate with carpet bombing. She wasn't an industrial complex where hitting anywhere in a 2-mile radius counted as success. The Tirpitz was a 52,600-ton battleship wrapped in armor that had turned away every conventional weapon the Royal Air Force possessed. Her belt armor ranged from 12.6 to 14.1 inches of face-hardened Krupp steel. Her deck armor, 4.7 inches of Wotan heart plate designed to shatter armor-piercing bombs on impact. But the real protection wasn't the steel, it was the geography. Tromsø Fjord sits 200 miles inside the Arctic Circle, surrounded by mountains that create unpredictable wind patterns, thermal updrafts that can throw a bomb hundreds of yards off course, downdrafts that collapse altitude in seconds. The Germans had installed smoke generators around the entire anchorage, 47 individual units that could blanket the fjord in white chemical fog within 90 seconds of an air raid warning. And the flak. God, the flak. The defense perimeter included 88 20mm autocannons, 16 40mm Bofors guns, and 24 88mm heavy flak cannons. Each 88mm could fire 15 rounds per minute to an effective ceiling of 26,000 feet. The shells were fused to detonate at specific altitudes, creating a 3-dimensional kill zone where every cubic meter of air could be filled with shrapnel at precisely the moment your aircraft passed through it. This was the target. This was what 3 years of failed attacks, Operation Tungsten, Operation Planet, Operation Brawn, Operation Mascot, had tried and failed to destroy. Hundreds of sorties, thousands of bombs dropped, superficial damage at best. The problem was fundamental. Conventional bombing from medium altitude was mathematically incapable of achieving the precision needed. A standard bombing run from 10,000 feet, even with the Norden bombsight, had a circular error probable, the radius within which 50% of bombs would land, of roughly 1,200 feet. For a target the size of the Tirpitz, this meant most bombs missed entirely. But in 1944, the RAF had developed a weapon system that changed the equation. The Tall Boy earthquake bomb, paired with the SABS Mark 14 bombsight. The Tall Boy wasn't just a large bomb, it was a 21-foot-long, 12,000-pound instrument of seismic warfare, machined from a single forging of high-tensile steel to tolerances normally reserved for naval gun shells. Streamlined to minimize drag, designed to reach supersonic velocities in freefall, filled with 5,200 pounds of Tirpitz explosive. When dropped from extreme altitude and buried deep underground before detonation, it created a camouflage effect, an underground cavity that liquefied surrounding soil and caused targets to collapse into the earth itself. But precision weapons demand precision delivery, and precision delivery demanded the SABS Mark 14. This wasn't the Norden. The SABS was designed for a single bomber dropping a single bomb with an error margin measured in yards. It was an analog computer that calculated wind drift at altitude, air density, temperature variations, the ballistic coefficient of the specific tall boy being carried, the ground speed of the aircraft, the rate of change of the bearing angle to target. And it required one thing that made veteran bomber crews physically ill: a perfectly straight, perfectly level bombing run. No evasion, no jinking. 60 uninterrupted seconds where the aircraft became a predictable target that every flak gunner could track. That's the dead man's run. 60 seconds where mathematics determines if you survive. Before November 12, 1944, before the dead man's run succeeded, you need to understand how many men died learning that conventional courage couldn't defeat the Tirpitz. September 1943, Operation Source. This is where desperation reached its purest form. 6 X-craft midget submarines, each one 48 feet long, 6 feet in diameter, carrying 4 men and 2 tons of Amitex explosives. The mission was to navigate 1,200 miles of Nazi-occupied Norwegian waters, penetrate Kofjord's anti-submarine defenses, attach explosive charges to the Tirpitz's hull, and escape before detonation. Lieutenant Donald Cameron commanded X6. Listen to how he described the final approach. The gyro compass failed. The periscope wouldn't retract properly. Every time we surfaced, it stuck up like a flagpole advertising our position. The depth gauge was reading 30 feet off true. For the last 11 hours, I navigated by dead reckoning through a fjord where 1 degree of error meant detonating against a cliff face or surfacing under a destroyer's propellers. They succeeded. X6 and X7 placed 4 2-ton mines directly beneath the Tirpitz's machinery spaces. The detonation lifted the 52,600-ton battleship 5 feet out of the water. Turbine mountings cracked, electrical systems failed across 3 decks, and the armor? Untouched. The torpedo defense system, 5 separate bulkheads designed to absorb underwater explosions, performed exactly as intended. The Tirpitz was crippled, yes, out of action for months, absolutely, but her structural integrity remained fundamentally intact. Cameron received a Victoria Cross, but his courage had only proven what the Admiralty already suspected. You cannot defeat engineering with bravery alone. The bomber attacks continued through 1944,
each one a variation on the same theme. Brave men flying into a kill zone, dropping weapons that mathematically could not achieve penetration, dying to learn what the physics had already predicted. Operation Tungsten, April 1944. 40 Barracuda dive bombers, direct hits recorded, superstructure shredded, 122 German sailors killed. The armor belt wasn't scratched. Operation Planet, April 1944. 27 Lancasters dropping 500 and 1,000-pound bombs from medium altitude. Results: superficial damage. Cost: 2 aircraft lost to flak. The lesson was brutal and repetitive. Conventional ordnance could not generate the kinetic energy needed to penetrate the Tirpitz's defenses. Standard bombs, even armor-piercing variants, dissipated their energy across the surface area of impact. The steel, designed specifically to resist this attack profile, did exactly what Krupp's engineers promised it would do. By autumn 1944, Air Marshal Arthur Harris understood the equation. To sink the Tirpitz, you needed a weapon that didn't try to break through armor. You needed to destroy the ground beneath her. Enter 617 Squadron, the Dam Busters. By November 1944, they'd evolved from the unit famous for bouncing bombs into German reservoirs to the only squadron in the RAF trained for precision high-altitude strikes with tall boys. Their Lancasters were modified, Merlin engines boosted to 1,620 horsepower, armor stripped to reduce weight, bomb bays enlarged to accommodate the tall boys' massive dimensions. But the modification that mattered most was psychological. Every pilot, every bombardier, every flight engineer in 617 Squadron had been trained to accept the mathematics of the dead man's run. They'd practiced over bombing ranges in Scotland, flying straight and level while instructors timed them with stopwatches. 60 seconds, no deviation. The instructors didn't fire at them, but the crews knew what was coming. Because precision bombing isn't about aiming at the target. It's about accepting that for 60 seconds, you become the target. November 12, 1944. The weather window opened. Wing Commander James Willie Tate led 32 Lancaster bombers north from Lossiemouth, Scotland. Each aircraft carried one tall boy, one chance, one bomb run. The flight to Tromsø took 3 hours. 3 hours where crews sat with the knowledge of what was coming. Flight Lieutenant Bruce Buckham, Bombardier and Lancaster PB-416, later described the approach. You don't think about the 60 seconds yet. You think about the navigation, the fuel calculations, whether the SABS is calibrated correctly. You fill your mind with numbers, because if you start thinking about the dead man's run too early, your hands start shaking, and shaking hands can't operate the bomb sight. At 8:30 a.m., they crossed the Norwegian coast. The Tirpitz's radar operators picked them up immediately. Air raid sirens wailed across Tromsø Fjord. Smoke generators ignited, white chemical clouds beginning to billow across the water. But the Germans had made one fatal error. They'd moved the Tirpitz into shallow water near shore, thinking it would prevent capsizing if she took torpedo damage. They'd anchored their fortress in a geological trap, sediment and silt instead of bedrock, the perfect medium for earthquake bombs. At 8:41 a.m., the Lancasters began their approach run from 14,000 feet. This is where the mathematics becomes terror. The SABS bombsight required specific conditions to function. Wind speed and direction had to be measured accurately at altitude and adjusted for changes as the bomb fell. The aircraft's ground speed had to remain constant. Variations of even 5 miles per hour would throw calculations off. The bearing to target had to change at a predictable rate, which meant no turns, no climbs, no dives. The bombardier watched through the optical sight as the target crept into the crosshairs, but he couldn't release yet. The SABS computer, a mechanical analog device using gears and cams, was still calculating, solving differential equations in brass and steel. The bombardier's job was to keep the crosshairs on target while the computer determined the exact microsecond when release would result in impact. 60 seconds. The stopwatch started, and the Germans opened fire. The 88mm flak cannons weren't firing blind. German gunners had been tracking bomber formations for years. They knew the altitude. They knew the approach vector. They knew that precision bombing demanded straight, level flight. They fused their shells to detonate at 14,000 feet. Flight Lieutenant Tony Iveson, flying Lancaster ME-560, described it. The flak bursts looked like black flowers blooming in sequence. You'd see one explode 100 yards ahead, then another 50 yards ahead, then one close enough that you could hear the shrapnel rattle against the fuselage. They weren't guessing. They were walking the barrage toward you, and you couldn't turn away. The SABS needed another 45 seconds. Inside the aircraft, every man experienced the same calculation playing out in real time, probability versus duty. Every second of straight flight increased the accuracy of anti-aircraft fire. The German gunners were solving the same ballistics problem as the SABS, just in reverse. They were calculating where the bomber would be in 3 seconds, 5 seconds, 10 seconds, and firing shells fused to explode at that exact point in space and time. The only defense was to break formation, to dive, turn, do anything to make yourself unpredictable. But breaking formation meant the mission failed. 3 years of development, Barnes-Wallace's revolutionary weapon, the strategic imperative to eliminate the Tirpitz, all of it meaningless if you flinched. This is the dead man's run. This is mathematical terror, knowing that the longer you fly predictably, the higher the probability that the next shell has your name on it, and flying straight anyway because the equation demands it. 30 seconds gone. The SABS computer still calculating. Flak bursts were bracketing the formation now. Squadron leader Tony Iveson saw Lancaster JB-139 take a direct hit, the arbored wing folding upward as if hinged, the aircraft beginning its death spiral with the tall boy still in the bomb bay. 7 men dead in the time the wing to tear away. 45 seconds. Bruce Buckham kept his eye pressed to the SABS sight, hands making microscopic adjustments to keep the crosshair centered on the gray shape of the Tirpitz, partially visible through the smoke. The optical tracking had to be perfect. Any deviation, even a few millimeters, would be magnified over 14,000 feet of fall. The aircraft shuddered. Shrapnel from a near miss punched through the fuselage. The flight engineer called out the damage, hydraulic leak, no immediate danger, but Buckham couldn't break his focus. The SABS didn't care about shrapnel, it only cared about the bearing angle. 55 seconds. Then the release mechanism triggered. The tall boy dropped free. The Lancaster lurched upward, suddenly at 12,000 pounds lighter. Pilot James Tate immediately threw the aircraft into a diving turn, abandoning the straight and level flight path that had made them a target. Behind them, the other Lancasters were releasing their tall boys in sequence, each enduring their own 60 seconds of mathematical terror. 21 feet of machined steel fell through 14,000 feet of Arctic air. The tall boy's offset fins induced a slow rotation, keeping it perfectly vertical, perfectly stable. At terminal velocity, it was moving at over 750 miles per hour. The bombardiers couldn't see the impact. They were diving away, trying to get out of the flak zone. But they'd done the mathematics. They'd flown the dead man's run. Now, physics would determine if 60 seconds of terror was enough.
8:47 a.m. The first tall boy struck. Inside the Tirpitz, able seaman Werner Hirsch heard it coming, a sound unlike any conventional bomb, a descending shriek that seemed to tear the air itself. He pressed his hands against the 16-inch armor of turret Anton, steel that had protected him through 3 years of air raids. The first tall boy hit the water 40 yards from the port side. In conventional bombing, this would have been a near miss. In earthquake bombing, it was a death sentence. The weapon punched through 30 feet of seabed before detonating. 12,000 pounds of Torpex exploding not in air or water, but in incompressible earth. The shock wave traveled laterally through the substrate at 13,000 feet per second, a pressure wave that treated soil like a fluid under compression. The second tall boy struck near the stern, then a direct hit amidships, punching through the armored deck, not because it penetrated the armor in the traditional sense, but because the kinetic energy at 750 miles per hour impact was equivalent to a shaped charge weapon. Then another near miss, another underground detonation, another seismic hammer blow. The effects compounded. Each explosion sent pressure waves through the sediment, oscillations that exceeded the load-bearing capacity of the silt and sand. The soil began to behave according to principles that wouldn't be fully understood until decades later: liquefaction dynamics. When saturated soil is subjected to rapid pressure oscillations, the water between sediment particles can't drain fast enough. The soil structure collapses, friction between particles disappears, the ground stops acting like a solid and starts acting like a fluid, quicksand on a geological scale. The Tirpitz, all 52,600 tons of her, was sitting on ground that was turning to liquid beneath her keel. Inside the ship, the damage was catastrophic, but not in the way conventional bombing would have caused it. The hull wasn't breached by shrapnel. The armor wasn't penetrated by blast. Instead, the entire structure began to twist. Frames bent. The keel itself, the structural spine of the ship, began to deform as the foundation beneath it disappeared. At 8:50 a.m., 3 minutes after the first tall boy impact, the Tirpitz began to capsize. Werner Hirsch, trapped in turret Anton as the deck tilted past 45 degrees, experienced what hundreds of men experienced simultaneously: the realization that the armor designed to protect them had become their tomb. 16 inches of croup steel that couldn't be penetrated by bombs now couldn't be cut through by rescuers. The dead man's run lasted 60 seconds. The mathematics had been perfect. The terror had been justified. The tall boy didn't just sink the Tirpitz. It proved a principle that would define modern warfare. In the age of precision weapons, courage becomes a mathematical input. For centuries, military valor was about charging into danger despite uncertainty. The brave soldier, the heroic pilot, the fearless sailor. These were people who acted in spite of not knowing the odds. Courage meant embracing unpredictability. The dead man's run inverted that equation. Every man in 617 Squadron knew exactly what the 60 seconds demanded. They'd calculated the probability of flak hits. They'd seen the aircraft losses. They understood that flying straight and level through a defensive perimeter that had been specifically designed to kill aircraft flying straight and level was suicide by mathematics. And they did it anyway, not despite knowing the odds, but because they knew them.
That's a different kind of courage. That's the courage of engineers, of test pilots, of people who look at an equation that says 30% chance of death and say acceptable parameters for mission success. Wing Commander Willie Tate, who led the November 12th raid, later wrote, "The terror wasn't the flak. We'd flown through flak before. The terror was watching the stopwatch and knowing that every second we stayed on course, the German gunners were solving the same problem we were. They knew where we'd be. We knew they knew, and the mission demanded we be there anyway." That's the dead man's run. That's mathematical terror. The technology that made it necessary, precision bomb sights, seismic weapons, calculated bombing runs, didn't make war less terrifying. It made terror measurable. You could quantify your chances of death down to the second, the degree of bearing, the altitude deviation. And if you were Bruce Buckham, eye pressed to the SABS bomb site, hands making micrometer adjustments while shrapnel punched through the fuselage around you, you accepted those numbers and flew anyway. By the end of World War II, the Tall Boy and its larger successor, the Grand Slam, had destroyed every hardened target they'd been used against. Viaducts that conventional bombing couldn't touch, U-boat pens buried under 20 feet of reinforced concrete, V-2 rocket storage bunkers carved into hillsides. The earthquake bomb concept had made fortresses obsolete. But the human cost was measured in those 60-second increments. Every successful precision strike represented bomber crews who'd flown the dead man's run and survived. For every crew that survived, there were crews like the 7 men in Lancaster JB-139 who didn't make it through their 60 seconds. The wreck of the Tirpitz still sits in Tromsø Fjord. In 1957, salvage crews cut her apart for scrap, the armor that had resisted everything finally yielding to peacetime blowtorches. But the legacy of November 12, 1944, isn't the destruction of one battleship. It's the moment when warfare became an equation, where courage was a variable you could solve for. The question worth asking, in modern warfare, where precision is measured in meters and strikes can be calculated with GPS accuracy, where the dead man's run has been replaced by computer-guided munitions dropped from aircraft the enemy never sees, have we eliminated the terror or just removed the 60 seconds where human beings had to choose to fly straight into it? Because the mathematics that killed Werner Hirsch and nearly killed Bruce Buckham are still being calculated. We've just automated the terror out of human hands. Or have we simply made the 60 seconds invisible?